Section 2.1 Angles, Arc Length, and Circular Motion. Welcome to trigonometry. Trigonometry is the study of triangle measurement. To kick things off, we are going to talk about some angle terminology. So hopefully you have an idea of angles from a previous high school geometry class. So we're going to refresh your memory about angles and kind of talk about some of the terminology you'll hear associated with angles from a trigonometric perspective. So what I have here are two pictures, and then below the pictures are some vocabulary words that kind of go along with the pictures. So let's take a look. First of all, let's talk about what an angle is. Okay, so basically an angle is formed by rotating a ray, which is a half line, about its endpoint. The endpoint of that ray is called the vertex. And then if you look at the picture here, you notice that every angle has two sides to it. There's an initial side and there's a terminal side. So the initial side is the starting position of the ray, and then what happens here, so if we look at this picture right here, here's the initial side of your angle. Okay, your ray, you have a ray that starts somewhere, and then there is some rotation that occurs. Okay, so that initial side is rotated a certain amount and it ends up somewhere, and that is where you draw the other ray. Okay, or the other side, that is the terminal side. The terminal side of the angle is the ending position of the ray or the angle. Okay, so basically what you can see from this picture is that every angle has three components. There is an initial side, the starting ray, and then it rotates a certain amount and it ends up somewhere, and that forms the other side of the angle, which is the terminal side. And then both of the rays are joined by the vertex, which is the endpoint of the angle. All right, so in trig, we deal mostly with angles that are in standard position, so we need to talk about what that means. If an angle is in standard position, that means that the vertex has to be at the origin of the rectangular coordinate plane. And if you remember, the origin is the point 0, 0. Okay. In addition to having the vertex be located at the origin, the initial side of the angle also has to coincide with the positive x-axis. So both of those things have to happen in order for your angle to be in standard position. So if you take a look at the second picture that I have up here, there are two angles involved in this picture. Both of them are in standard position. Okay, so if you take a look, for both angles, the vertex is at the point 0, 0, the origin where the x-axis and the y-axis coincide, and then the initial side of each angle, which I'll highlight in yellow, it falls along the positive x-axis. Okay, so what the difference is between these two angles that are in this picture is that one is a positive angle and the other angle is a negative angle. So if we scroll down, we can talk about what the difference is between a positive angle and a negative angle. You will see both positive angles and negative angles in trig, so you absolutely have to know what the difference between the two is. Okay, basically, how to tell the difference between a positive angle and a negative angle, it depends on the direction of rotation. Positive angles are formed by counterclockwise rotation. Negative angles are formed from clockwise rotation. Okay, so I have the little symbols there to remind you what clockwise is versus counterclockwise. If you forget, or you have trouble visualizing this, just think about a clock and how a clock moves, especially a clock where you can actually physically see the seconds hand moving in real time. Okay, so if you're dealing with an angle that is formed by rotating the same direction a clock would move, that's going to be a negative angle because the rotation is clockwise. If your angle is formed by rotating in such a way that is opposite of what a clock does, that's going to be counterclockwise rotation, and you'll have a positive angle. Okay, so if we go back up to this picture, let's take a look at this. So if you have your initial side and you have your vertex, if we start with the initial side and the rotation kind of goes up this way, okay, so think about that red arrow I just drew. It's going this way. Okay, it's going opposite the direction a clock would go. So that is counterclockwise rotation. And so this angle, where you start with the yellow initial side and then we rotate it through a certain amount, marked by this red arrow, and then we end up here. Here's the terminal side. This is a positive angle because the ray, or sorry, the angle that is formed from the blue ray and the yellow ray, it was formed through counterclockwise rotation. Okay, so that is a positive angle in standard form. Okay, on the flip side, we could have rotated down. So if we had taken the initial side and rotated down this way and ended up here, so the terminal side lands here in green. Okay, basically if you start with the yellow side and you rotate through to the green side, that rotation is in this direction. Okay, it's in the same direction that a clock would move, so this would be clockwise rotation, so that's going to be a negative angle. Okay, so again, all the difference is between a positive angle versus a negative angle is the direction of rotation. Okay, so if you rotate in a clockwise direction, that's going to be a negative angle. If you rotate in a counterclockwise direction, that is a positive angle. All right, couple more terms. So if we jump down here, let's talk about coterminal angles. Coterminal angles are angles having the same initial and terminal sides. Okay, they are different angles, okay, because there's going to be a different amount of rotation in each, but they're going to have the same initial and terminal side. So they'll have the same starting point and the same ending point. So if we do 1/4 of a rotation and then we do 1 1/4 rotations, for example, we have performed two different actions, meaning the amount of rotation is different in each situation. However, if you drew this out, the terminal side will be the same. Okay, so again, all coterminal angles, what they are, you have two different angles. There's a different amount of rotation in each, but the starting point, the initial side and the terminal side, those two sides are the same for both angles. Okay, coterminal angles are probably, that term is probably a little difficult to kind of grasp until you see an example. We will do an example very shortly and it'll probably make a lot more sense, so hang tight. All right, as far as how to describe angles in trig, when referring to an angle, we usually use lowercase Greek letters such as alpha, beta, and theta. Just as x is the go-to variable in terms of an algebraic unknown, theta is usually used for an unknown angle. Capital letters in the English alphabet like A, B, and C may also be used to name an angle. Okay? All right, so in trig, a lot of the times you might be asked to solve for an angle. Okay, angles are usually designated with these lowercase Greek letters. That doesn't mean you need to go out and learn the Greek alphabet. You just need to be aware of, the common symbols you might see. So alpha, here's the symbol for alpha, and then here's the symbol for beta, and then the most popular one is going to be theta, so that's its symbol. So if you see these Greek letters, they're usually going to be referring to an angle, but you may also see an angle designated in terms of good old A, B, and C from the English language. So just capital letters from the English alphabet as well. Okay. All right. As far as measuring angles, okay, if you've taken geometry before, you've measured angles in degrees. Okay, so maybe you remember from taking that class, you pulled out your protractor and you drew an angle in degrees, or you measured an angle in degrees. Everything was done in degrees. Okay, there are other ways to measure angles, and you will see some different representations of angle measure in trigonometry. Okay, in trig, the two commonly used measures for angles are degrees, which you're hopefully used to, and radians. Okay, you may not have dealt with radians before. It may be a new concept. It probably will be a new concept to you. Radians is just another way of measuring an angle. Okay, it's gonna take some getting used to. Okay, so I'm just giving you a word of warning. But in trig, we will concentrate on measuring angles in both degrees and radians. Okay, so why are there different ways of measuring angles? Well, here's a good way of thinking about it. Just like length, there are a multitude of ways to represent it. If you are measuring the length of a picture, inches might be appropriate, while the distance between two cities is better measured in miles. Okay, so something like length. We deal with length in everyday life. Okay, there's multiple ways to measure length. You can measure length in feet or inches or miles or meters. There's lots of different ways to measure length. So the same thing is going to be, the same thing will happen with angles. Okay, there's multiple ways of measuring angles. The biggies are degrees and radians. In this section, section 2.1, we're going to start by reviewing degree measurement, and then we're going to start discussing radians. Okay, you're going to learn what a radian is, how you measure angles in radians, and then we're going to talk about how to convert between the two measurements. Okay, so like think about length. Okay, miles and feet. Okay, you might have to make a conversion. If something's measured in feet, you might need to convert it to miles and vice versa. Okay, so you might have an angle in degrees and you may need to convert it to radians, or vice versa. Maybe you have an angle in radians and you need to change it over to degrees. So that's what we're going to concentrate on in this section, reviewing degree measurement, learning about what radian measure is, and then talking about how to convert between the two.